Let's take a few minutes to look at the check drawing project that we did, kind of review it, understand what my rationale was for it, and help you reflect on how you did on it. Um, in the first part, when I think about grading or looking at this, I went through that narrative myself and reconstructed the model this year, or actually last year. So we're looking at a drawing on the left-hand side here of the work that I did, just in preparation for understanding what would happen when projects were submitted and I didn't see things that might look quite right. One of those was that this anticipation that elevation views that are rendered in architectural presentation style are kind of locked into that 1/8 inch scale, and that frustrated a few people. But that was totally acceptable on this presentation sheet because it's so large. But anyway, those kind of familiarities with what issues students would have. And on the left-hand side here, that's a student, or excuse me, on the right-hand side here, this is students' work. And in many ways, it looks a little bit superior to my work. It looks like in the floor plan, they did more dimensioning. The views might be a little better constructed. But I think the only thing I see wrong here is that they didn't actually cut a tower section, and I'm not actually seeing the section view here. But in many ways, this is a pretty good project. And let's take a look at, the kind of scheming that I came up with to think about grading. Because these are kind of like the metrics or milestones that I think are important for you to be competent, to be able to use these kind of modeling tools to communicate architectural ideas, both in professional practice, if you were to start as an intern, and or in studio work, just to develop clear and coherent ideas that you have into presentable projects. So the first goal was to see that you could bring on a construction sheet or a drawing sheet, and then drag your views onto it and organize them. The ability to create grids and levels, the understanding of that, I think are critical to helping you lay out components accurately. The idea of creating roofs with overhangs, understanding that basic concept. We have that separate issue of the shed roof, which we'll discuss at the end. And then the idea of putting in storefront glazing, to quickly kind of create a fenestration to the building. And that kind of trips up a lot of students because for good reasons, because many times you'll try to put in storefront glazing, you'll be looking under the window tool, and it's really a wall tool. So it really talks about how well practiced you are in using the software. The ability to dimension the floor plan, at least a rudimentary ability to dimension it and pull dimensions off of it. To generate a rendered elevation, a isometric, to understand the idea of an isometric view, and then this idea of creating a section. So in this case, that tower section, a lot of people got quite a few, surprisingly, weren't able to accurately cut a tower section through. They would put the sections outside of that area and really show the tower as an elevation instead of a cut through. But one of the clear things of the kind of the depth of skills that you've learned. And then we have this idea of putting a shed roof on. Many of you put on a hip roof and with a pitch to it, which was close, but a shed roof is a single pitched roof. Some people may have used the internet to go out and search for that, and that actually would have been considered okay. Some of you may have felt uncomfortable doing that, thinking it was cheating, and that's also okay. I only really took 1 point off for that, so if you lost a point for the shed roof, really don't beat yourself up too much about it. It's a really common error, and just what kind of fell into the place of grading for that. And important to note that none of this grade is counted towards your final grade. This is really an assessment to make sure that you've accommodated these basic skills. I'll use it as a guide towards making some determinations towards final grade, but it won't go into the actual number count. So here's some exemplary work by a student. Had good command of the software, so they had the time to kind of deal with maybe some issues that I didn't do. They embellished the tower window. They were able to put a shed roof on. They were able to be, I guess, a little uncomfortable about the fact that I hadn't placed a door into the opening, and so they went ahead and did that. And then this student here was able to work with some materiality, got the concepts of the shed roofs right, and added some doors in for that concern about not having any entries to the spaces we created. And then one student who has a really good command of the software probably from prior experience. I'm not going to put words in their mouths. That may not actually be, in fact, the case. It'd be interesting. I wish we were together so we could discuss that. But here we have this really nice context built along around it, but this student actually got a 9 out of 10 because they didn't actually create the shed roof. And I'm also noticing that their section cut did not go through the tower. So really nice work, but still not completely perfect. So we all have room for I guess seeing these things as we go through our process of learning. So one of the things I always harp on, this idea of perspective distortion, vertical perspective distortion, something that's really important in communicating in the horizontal plane of communicating depth of our architecture, but it's really problematic when it is vertical. So here we have this idea of converging lines. I made 2 screenshots of a cube. In the first cube, the incorrect way, I have a low eye elevation and a high target elevation. So I'm looking up at the architecture and it's modeling it with perspective, so the top looks smaller than the bottom. And then on the right here, I have it correctly rendered. So we have now vertical lines that aren't converging on each other, and that's because the eye and target elevation are identical with each other. And I think you can include mostly anything you want about your architecture. You can get almost any view you want without having to alter the eye and target elevation. And so I wanted to point out why I think this is problematic, and the next image kind of goes to that point. So here we have the building that we worked on, and these 4 images that I've gathered up here on the right here. I think if I was to ask you in class, the takeaway from these images is they have a cartoony appearance to them, that kind of forced perspective in the vertical plane, and I think if you were to study these images for a few minutes and then look over to our original object, you might now be impressed with the idea that it has that kind of cartoonish look to it because of that kind of vertical perspective distortion. So imagine someone looking at your architecture, wondering why it doesn't have a serious professional feeling to it, why it has a cartoon feeling without actually drawing reference to these images that I have here, but to references to images that they've seen in the past of cartoon portrayals of architecture. So I hope that helps to kind of cement that idea of making sure your vertical lines are vertical. A criticism by one of the students I think is really useful. There should be 2 of these kind of check drawings that happen through the semester, and I think that's a good point. I think it helps to gain a certain level of confidence about the work that you're doing. My only concern is how do I fit it in with lecture and the kind of in-class assignments that we're doing. But if anyone has also strong feelings about that, please add some commentary. Send me an email. I'll be happy to read it. So I'll pick this up in the next clip.